Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. We are on a challenge to continue what should be the debugger loop, and that's what we will do today. So yeah, welcome everyone, and yeah, if I say if you would like some questions, please ask them after the stream has ended. And yeah, so let's just start with this. I have already opened for coder, and as you remember, we left off where we created a thread in the same process as Win32 EagleFly, and we will use this thread to dispatch all the messages that the tracer is gonna leave to us. So that we don't need to wait for them, because that's important. We don't need to wait for them to start rendering stuff, and that's important. We want that to be independent. So once we did that, what we can do is to go to tracer data. This tracer data is the input that the debugger itself is gonna send to this callback that we made. It's basically debug tracer callback. And what debug tracer callback is, it's just now some kind of prototype for the function that we would like to do. And basically what it does is just create the process where the target debuggy is gonna run on, and yeah, that's all. And the thing that yesterday we didn't really make sure about is, like, we weren't catching this we weren't catching this how does all this work, because now that I remember, the thing that was happening before is that we were never catching the end of the process, and that was like kind of interesting, because you're like, why doesn't the process was running at all? And now that I think about it, the reason was because I remember reading something about when we run a process as a debuggy, when we have this flag here, the process is gonna start and it's gonna have a markup that it's gonna have a lock, and yeah, it's gonna have some kind of locking, where it's just gonna start in lock, and there's one it's gonna be waiting for us to send a flag or a signal that it's gonna receive, so that we can process it, and that's interesting, bro. Because I think that's the next thing to do, So let's see if we can go directly to there and verify that. Verify our assumption. Let me go to here, and the function I was looking for is this one. Basically this one is the one that is going to receive the signal, because remember, the signal comes from the debuggy, and us as debuggers want that signal to continue and to start processing the message. So what we can do is something like this. I don't know if, for example, I'm not kind of used to this kind of syntax, but I don't know if it's kind of useful to say that we have something as an out parameter or as an in. I mean, probably it's gonna be useful, at least for, I mean, if we want somebody else to read this kind of code. Yeah, it's, I mean, it's understandable, you know. At least I think so. Yeah, I think it's more understandable than not specifying a noun parameter. So we can move this. We'll need it right now. And you know, also this is important because we want to isolate the thread that creates this process, so that, I mean, as you can see here, only the thread that created process can call for wait debug event. So that means that the thread that we are using, that we isolated from, in this case from the main from the main processing of the platform layer. That means that we now have an isolated set, an isolated thread that controls and receives and gathers all the data from the target, and that's what we want. We don't want to flew the all the platform layer with messages or things that the target application is sending to us, if that makes sense. Okay, so this thing is kind of interesting. I mean, this sets us for success in the sense that if we like to process different threads across the process that we are debugging, we can control it with this function, so that well, in the case that we would like to advance through a thread, you know, but the other threads will be like kind of stopped, you know, and probably well, I don't know, but this lets us to advance in a process and probably stalling into the others, or well, I have no idea, but we could. I mean, this only lets us to specify which thread we want to continue processing information from. But I don't know what does it do. What does it do for the other threads that are contiguous inside the process? Okay, so if we use suspend thread, the debugger can resume the other threads in the process. It's like yeah, like reprocesses the whole stack or the whole process. I mean, but that's kind of janky because I mean, if what if the other processes, the other threads needed some kind of information to be processed by the thread that we suspend? What would happen then? this means that we can, or we should at least, limit the set of threads that can execute within a process. Oh, okay. This is interesting. So if we use, I mean, we suspend all the threads, and we just let one to be processed, uh, to let it go. I mean, to get to read the process from it, or read the data from it. If we then call to the continue, it will not continue. You know. So all those threads will be stalled, and we need to use the resume thread to stop and continue. I still have my doubts of how to, or why should we use that form of structurizing, but you know, we can take a look later. So for now, we just want a simple, let's say that something like this, you know, and something like this, I guess. I mean, I think I mean, we have the process ID, I believe, in the process info that we have, but we can have it here also, I guess. We can assert this, you know. So we know, at least for now, know that it's the same process, you know, that we are processing. So we have, I don't know if it was here. And this is process information. Yeah, I believe it's here. What the hell is this? Here you go. This is the one I was looking for. So we can start by looking at these events one by one. So we can use this handle to basically write to the file as a standard writing that we could do. So hey, I mean, we have here the basic essentials. We can write to the file, or we can write to the process memory space inside the process. So we can set the context for the frame, get the context, and use these kind of suspend resume things for the thread. So I mean, what is in the registers, that's the thing that we could dump as a register image or something, So we want to see how do we want to process all this information that we are getting from the target, because since it's a lot of information, we have to make sense of it somehow and to process it. So let me see. So we got all that, and that, I mean, that's well, that's one of the most important parts of. These were one of the most important parts for the for gathering information, setting information through the process, and then we have the base of image. And we can gather the base address for the image. Alright. Okay, so what debug information does the file have? Okay, it could not have any information. And even though we are not using thread local storage for handling thread storage or any kind of that thing, probably the target user is gonna have. It can have anything. We cannot assume that something is there or not. That's like the basic thing to see, to have a perspective from. So we should and this is the kind of a tricky thing, because we have to handle at least the most or more of the possibilities of what the in the sense of just of having robustness. So in this case, probably it's going to have thread local storage, and we have to have a way to at least to show that information. It can be a separate thing as thread local storage, or it can be, I don't know, in the sense of how we want to display that information, but it's something that we also have to show. Jesus Christ. No, I don't want any kind of update right now, please, Mr. Windows. And also I should lower the volume because, man, that was hard. Okay, this has a good working set, you know. We have a full local base and store address of the thread that we are looking at. This value may only be an approximation of the thread storing address, because any application with appropriate access to the thread can change the thread's context by using the set thread context function. A pointer to the storing address of the thread may only be an approximation of the thread's storing address. Okay, so it may because any application with appropriate access to the thread can change the thread's context by using the thread context function. Okay, so what does that imply? I mean so we can change the context, and this I'll assume that this is the context. Okay, so each processor architecture is going to have different structures. So we should look at this in a second. I mean, it's not we don't have to look at it right now, but yeah, I mean, we have to know that this is per processor, so we have to have a specific structures for each one if we want to change the context, of course. Store address, okay, that's not kind of reliable, I'll assume. So yeah, this is the other call that we probably will use, and this is for attaching to the debugger, to the target, sorry. We got the process and boom, we start. But probably, I mean, that's another way to go, you know. But right now we don't have to care much about that. So yeah, so this is the first structure, and I would like to parse that first because it has sensible information about what we would like to gather first. So let me go. To catch this, and I believe it's like you create process info. I'm gonna find that. My goodness, please. Here you go. Here you go. I mean, we can have something like this. And let me see. Alright, and we got the info, and now we can start to parse it so we can get the file handle. And for now, I mean, I don't know. Well, we can, let me see, we can try to I would like to see for the test one that we have. Let me, where is it? This one. I'd like to see if we can gather the registers themselves of the running process of the thread. You know, I mean, if we print, I mean, if we dump this as a binary. I can try, I guess. Let me see. I don't know if this is gonna have there you go. And I don't remember dumping. I don't know where the or I don't know where did he dump it. I don't see here. This Debug target. Necessary to EagleFly. Yeah, it's not here. I mean, we can do directives. This is just for what do we want to dump out, but we don't have a way to say that we want the binary to be out somewhere, you know. Or we can use the out option, so it can be something like this. Well, I don't know, where do I want it? Or yeah, okay, so we can do something like this. I don't know if we want it, but and we can just debug target.exe. And it's gonna take a while, I know. Probably I would say that we didn't need the whole data itself. But man, and look, I mean, this is just for I mean, for real things. This is the file, you know. This is the binary. It just has this, and look at that. Look at the whole thing that it has to. I mean, the whole set of well, the binary itself. I mean, the whole set of, I don't know, instructions and modules, and I don't know what else is there, you know, data, you know, the variables, the modules, the runtime library, you know, you can name it. Jesus, it's a lot. Can I say? There you go. Well, probably I didn't want it at all. So let me change this to something different. The headers probably it's gonna do it. The imports, the line numbers, the linker member. Yeah, because this is all the disassembly. We can do it with the headers, I guess. Dumping headers. There you go. It's for x64. Number of sections 6. It has a time, the file pointer to symbol table. We don't have symbols, number symbol, we don't have symbols. Size of optional header. The application can handle large addresses. Alright. We have a magic number that's 20p, p32 plus. We have a linker version. Size of code 33k. Initialized data 17k. Uninitialized data 0 entry point. Main C runtime startup. This is the one that's gonna call. So it's gonna call the C runtime library. The base of the code. $200 of file alignment. Yeah, we didn't specify that, so probably it's just a garbage there. Operating system version 6.0, the image version 0, subsystem version 6. We have a size of image for 550k, 400 types of headers. Alright, we have the size of the stack, it's 100k. Committed, it's 1k. We have heap, it's 100k, and they committed 1k. Load of flags, number of directories. Oh, so here you go. This is the thing we're looking. The global pointer, the fetch storage directory, load configuration, down import directory, import address table directory. So we have a, like, you know, this file is like a, it's it's like a TTF, you know. It's a bunch of directories, and I mean, I'm sorry, I mean it's not like a TTF, but I mean the idea of tables and directories. But yeah, forgive me of that. The thing here is that yeah, we have a bunch of directories, and in these directories where we can find all that data, these are the headers, and the headers serve as offsets and to parse the whole binary if we'd like to. So I'd like to see, first of all, it's not here, right here. Debuggers use the descriptor table entry to convert a segment relative address to a linear virtual address to read process memory. Okay, so read process memory and write process memory functions require linear virtual addresses. We can display the current instruction and register the values. We can start by that, I believe. Oh, okay. So if we modify the instructions in memory, for example, for setting a breakpoint, for example. That can be an example. uh, if we set a breakpoint, we will modify the process memory, but the CPU will not detect that change because it's not in the cache. So we need to call flush instruction cache to let the processor to know that, hey, I modified this thing. Please reload the cache with this new memory, and yeah. So it has to be a lock in there. I mean, it's already a lock because we're already debugging the process, but we have to have like that kind of synchronization with the processor, so him to know that we modify it. Okay, so this is the status that we set. Okay, okay, got it. I get it. we can say something like okay, so we should suspend the thread because I assume that it's not suspended. Okay. Okay, so output debug string is basically like that kind of a functionality where you let the process. I mean, if we put that when we were using output debug string, that was basically doing. We were communicating with the debugger. The debugger was just displaying that string on the output code. So we can do something like that. I think that's a good starter. And and this is resume, but this assumes a resume. But we have, if we suspend it, we should resume it as well. Alright, so now I think that we can try to do that. So I really like to do something more like this, you know. So yeah, I mean, we can process this and do something with it that we don't know what I'm going to do. Well, basically we can do this. So something like this. And for now we can say that we will, this is a get exit process, but we want to continue the process. uh, uh, uh. So we're gonna set it by default to debug continue. And we can handle depending on each event, which is nice. Debug exception not handled, debug reply later. In general, it's gonna be debug continue, I guess, but we can do that. Okay. So now, if we compile, we can start to solve these problems. And we have our reference local variables all over the place, which is fine. Create thread debug info. So the first thing, I mean, I'm not gonna care too much about this right now. I just want to pass to the exception one, so we can take a look on it. So we can probably do something like here. Let me go to the place where we right here, and I want to go, well, we have it here. And we want to get the exception debug info, and then we want to drag this. Well, first of all, before going deeper into this, I just want to see if we can let me see. We can. It's gonna be something like this, I guess. And I believe it's gonna be well, we can. For now, we don't care too much about processing this, so I wanna put it that way. And this is gonna be exit process, I believe. Yeah. Okay. So we just basically have the first thing where we just were keep processing messages, you know. So what I want to see is what does it happen, yeah. So we like to, we have a breakpoint there, so that's good. You can press 5 and see what's gonna happen. We're gonna process it. Oh, and I don't remember which process we were processing. So, oh, I know what. Okay, so let's see. We got the continue status. We wait for debug event. We got the out debug event. Is the code tree, and the process ID is blah 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 blah, which is the same as this one and as this one. Yep, that's correct. So the assertion passed, and now we can go to the specific switch, which is the create process debug event. So this is the first one that's got the kick all, you know. So we can get that, and we can see this to see what's going on here. We have a handle to the file, a handle to the process, a handle to the thread, the base image, we have a debug info file offset. We don't have a info for that, I believe. Yeah, we don't have it. We don't have thread local, well, yeah, we don't have a thread local base, which is that, but I believe we don't have anything there. And I'm sorry, we have a store address, and we have a image name, which is, well, we don't have an image name. and we have this, alright, and they have Unicode. I don't remember what was that for, but if it supported Unicode, isn't it? Yeah. Yeah. Alright, so that seems to work. And then we can say, hey, continue the status, alright. And then we say, hey, continue the status, and tell me now what you got. We don't process it because the event code was 6, and the 6 is I don't know what 6 is load DLL. Alright, so yeah, we have a DLL that it's gonna load. We don't process it right now, so we don't care. We continue. We have now a 6 that's a load DLL, another load. Well, we can have a lot of DLLs, so we can continue. Let me put, well, we have it there, isn't it? Well, let me see if we get so this is a load DLL. We have the base of DLL. So all the DLLs is going to be loaded. But there are a lot of DLLs. Let me see if we can get to somewhere in here, We have an exception. We have a break. And that's because the ID is the same for the process, but the thread is now not the same. And the reason for that could be, now we have event code of 2, which is to, we have a create thread debug event. So we created a thread. Okay, that makes sense. Well, we didn't create a thread, but this thing created a thread from where to execute. So if you see, first it loaded the DLLs and blah blah blah. Well, first it loaded the process, then loaded the DLLs and do all the stuff, and now it's loading, creating threads for it. So I believe, yeah, I mean, yeah, this is wrong here because we didn't know that. So let's move that out of there. So we don't need that basically. And the thing I would like to do, well, also for starters, I would like to, well, I think that's good. Let me continue. There you go. We created the debug event. That's fine. Then we got an exception. Nice. That's the thing that we were looking for. And that's number one. We have for the process and for the thread ID. So we can catch it per process and per thread ID. And we have what would be the exception. They have exception record. So let me see what can we do with that exception. Alright. Create thread debug event. We have exception. Let me go to the we have the if it's the first chance, so we can start by there because that's probably useful. Let me well can do here, I guess. How's it called? TW first chance. This is the first time. You can do it like this, I guess. First chance. Set a first chance and you know, and debuggers typically handle breakpoint single step exceptions when they are first encountered. So this depends on the hardware, because if the hardware doesn't allow bounce checking, we have to prevent that. Floating the normal operand, floating divided by 0, inexact result. The exponent of the floating point operation is greater than the magnitude allowed by the corresponding type. The stack overflow. An exception handler returned an invalid disposition to the exception dispatcher. Exception, non-continuable exception. A trace trap or other single instruction mechanism signals that one instruction has been executed. Yeah, the Control C, for example, the one that we used before for stuffing the dump binary. That's an exception. That's gonna be an exception for console processes, and we can gather that as well. The exception flags can be either 0, it can a continuable exception, or exception non-continuable. A pointer to an associated exception record structure. Okay, man, that's crazy. it's gonna, it's gonna have like chain of exceptions that it's gonna be, you know, bananas. Exception address, the address where the exception occur. All right. To enable a debugger to debug a target that is running on a different architecture, 32-bit versus 64, use one of the explicit forms of this structure. Alright? Alright. We need to gather. Okay, so we have to specify one specifically here. Yeah, forgive me for being redundant, but you know, that's how it goes. So we need to choose one of those, you know, and it depends because we don't know target. So we have to see what's the target, you know, and choose an adequate data to gather all the data, which is kind of interesting. Well, the only thing that I care right now is for the single step one, but yeah, there's a whole world there, you know. So we can do something like this, I guess, and we can go this route. And this has the exception code, but this has exception record. Something like that. And for example, this is the record, this is the code, this is the first chance. Yes, you see this first chance, and the code. Oh my god, what did I what did I did? Okay, no, I don't want that. And we have the flags. Doesn't have flags. It has another record added to it, chain it to it. You have the address of the exception, which is that. What's that? What's that? It's this one. It's this one. And we have exception information. No, we don't have it. How long is it? It's 15. Okay. And none of them are filled, isn't it? No. Alright. Alright. So we have this, and we can go to here, and we can say something like this. Oh, I always forget that it's not here. I don't care at all. I don't care at all. Where is it? We have that. We need that. We don't need this. There you go. And we could take a look at the single step. I mean, if this is single step, we have to gather the context, isn't it? Because this just tells us that it was a single step breakpoint, you know. Well, a single step. It's like, oh, you know, this thing has been executed or something. Only for the creative process being debugged. Okay. We have all this data, and I would like to go to right here. And the thing I was looking for we should update data for thread context, registers, and instruction. Next, instruction to execute, which for now I guess we can say something like output debug string, and we can say some kind of I don't know if we have. Do we have here standard IO, something like that? Do we have in the platform? Let me find standard IO. We do have it, and it's here. There you go. So we have a standard IO, and so I would like to go to thread. Here you go. And we have a standard IO, so we can do something like some printf.s, some kind of buffer, you know, some kind of size of the buffer, we format some parameters. So let me see, what can I do with this thing? Let me me see, for example, let me see what we can print out, or where we can find the next instruction to execute. That I believe it should be on the process. Oh no, it's right there, isn't it? Let me. It's in the here. It should be this address, isn't it? I'm not certain, but because we have a number of parameters and exception record, it's because this is exception, isn't it? I mean, this is not the instruction, I believe. So let me see. I mean, we know that we have a single step exception being passed there, and we can now. That's not exception flags. We have exception flags. We have. Let me do something here where we can do something like this. Exception. We have a record, and if that's where am I? That's this structure. There you go. And then we have a record, exception code, and we have the e-record data, how's it called, the flags, exception address, so we can pass it right here, and we can have something like that, and this is dot 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 this, how to say a 64, I don't remember. It was a U64, I don't remember, but we can take that so let me see, where can I find the instruction per se. I cannot find. Okay. you know what we can do for now. Let me see. Since we don't have much more time here, we can go more into the exception part later because it's gonna be a little bit more in there. But we can process output debug string, I believe. I can go to test debug target and include, let me see, we need windows.h. Let me see if we can do that. So what I would say is just that I want to do something like this, and we have an output debug string right here that we can use to see what's going on. And we can say output debug string oh yeah, so we need to read the process memory. Okay. and I believe this is debug string so we can basically do something like a red thing. So it's what? Okay, so it's a size t. So we can have a size t, number of bytes read, bytes read. So what that means is like something like this. And we can do something like this. And let me see if we can do this. We can do this. Well, this is a void pointer, isn't it? Oh, I think that's okay. And this is the size. This buffer is gonna be let me, for now I'm gonna malloc it because why not? Buffer, and this is gonna malloc it, and this is gonna be size. String size, I believe it's good. And we have u32, we have a sign in size equal to string size equal to debug string and debug string length. It includes the null terminator SQL from the debug string. If this member is 0, the debug string is empty. If it's not 0, the string is unicode. Okay. Okay. So only if debug string for now we're just pressing to do Alex process Unicode strings, and this is no debug string f Unicode, this is here, this is right here, and this is like that, and this is like this, and this is like this. we process the memory, we have a string size, it's this. This is the string size. And then we have the buffer, this is the buffer. And this is the base address, that's basically this, and there you go. Alright. We can basically do the same thing that we were trying to do there, and it's just gonna be we can, but we don't need that. I put the string buffer, there you go. Compile. We see here this has to be this. This is a pointer. And we cannot open this because, of course, we compile back. And another thing that, well, if we want to process this, let me change here the process that we were inspecting. Where is it? Here you go. We have a debug tracer callback, and the target's gonna be be is this, isn't it? Is no, it's not this. This is the exe, but we want, what's the name? Be build, and this is test debug target at the exit. There we go. For now it's gonna be like that. And this, oh, there we go. Alright, let me see if we can do it. Let's test this. I don't know what's gonna happen, but let's see. We don't have a pointer there, so we don't want that. We must want this, and well, why not that, and be run. We step into it, create a process, it gets initialized. We wait for the eval, the debug given code, it's gonna be a tree, that's initialization control. F10, we have a debug info, that's valid. We can see it here. For local base. Perfect. We don't do anything with that right now. So this is 6. I would like to continue, and now we see a window, and then we see exception debug event. I don't know the exception code what is. We don't do anything with that. There you go. We have the output debug string, and let me see what we can do. Is it's F Unicode, No, it's not. It's ANSI because we did it that way. So we have string length, it's 16. We have a malloc of string size. We have a reprocessed memory of 6 of size on the data and on the buffer, and there you go. Alright, we got the buffer. Hey, there you go. We read it. Awesome. We can output the debug string, and hey, you know, we get a string from other process, so we are communicating. Okay, that's good. We are in a process of communication. We can continue. There's a create thread, and if you see, actually that happened before the create thread and all the stuff. I don't know what this does. Let me see. Well, I don't know if you guys see it, but yeah, I forgot. Here's the hello front test. Yeah, because I remember that here's the real my face looking at. So yeah, if you like to see the hello front test, here it is. And this is a create thread. It's gonna create a thread, and yeah, you can continue. Hey, and we have the debug target being processed, which basically doesn't do anything because we didn't say to output debug string, and we don't have any standard test out thing. And we cannot close it because I believe, oh no, yeah, close it. That's crazy. Okay, so I think that's perfect. That's it. So it's good for today. We are communicating with the other process, and yeah, we can continue that route. We can continue. Alright, so thank you very much for coming up on this stream. Please, if you have any questions about what we did today, or of any question that you like to ask about the project, feel free to answer. I will be happy to answer them. And yeah, for now, I think that's all. And I will see you all on the next stream.